Tutorial 13, Airport Operations. This tutorial covers airport operations. Each time a pilot operates an aircraft, the flight normally begins and ends at an airport. An airport may be a small sod field or a large complex utilized by air carriers. This chapter examines airport operations, identifies features of an airport complex, and provides information on operating on or in the vicinity of an airport. Types of airports. There are two types of airports, towered and non-towered. These types can be further subdivided to civil airports, airports that are open to the general public, military federal government airports, airports operated by the military, National Aeronautics and Space Administration, NASA, or other agents of the federal government. Private airports, airports designated for private or restricted use only, not open to the general public. A towered airport has an operating control tower. Air Traffic Control, ATC, is responsible for providing the safe, orderly, and expeditious flow of air traffic at airports where the type of operations and/or volume of traffic requires such a service. Pilots operating from a towered airport are required to maintain two-way radio communications with air traffic controllers and to acknowledge and comply with their instructions. Pilots must advise ATC if they cannot comply with the instructions issued and request amended instructions. A pilot may deviate from an air traffic instruction in an emergency, but must advise ATC of the deviation as soon as possible. Non-towered airport. A non-towered airport does not have an operating control tower. Two-way radio communications are not required, although it is a good operating practice for pilots to transmit their intentions on the specified frequency for the benefit of other traffic in the area. The key to communicating at an airport without an operating control tower is selection of the correct common frequency. The acronym CTAF, which stands for Common Traffic Advisory Frequency, is synonymous with this program. A CTAF is a frequency designated for the purpose of carrying out airport advisory practices while operating to or from an airport without an operating control tower. The CTAF may be a Universal Integrated Community, UNICOM, Multicom, Flight Service Station, FSS, or tower frequency and is identified in appropriate aeronautical publications. UNICOM is a non-government air-ground radio communication station which may provide airport information at public-use airports where there is no tower or FSS. On pilot request, UNICOM stations may provide pilots with weather information, wind direction, the recommended runway, or other necessary information. If the UNICOM frequency is designated as the CTAF, it will be identified in appropriate aeronautical publications. This figure lists recommended communication procedures. More information on radio communications is discussed later in this tutorial. Sources for airport data. When a pilot flies into a different airport, it is important to review the current data for that airport. This data provides the pilot with information such as communication frequencies, services available, closed runways, or airport construction. Three common sources of information are aeronautical charts, Airport Facility Directory, AFD, and Notices to Airmen, NOTAMs. Aeronautical charts provide specific information on airports. Tutorial 15, Navigation, contains more information on interpreting aeronautical charts. The AFD provides the most comprehensive information on a given airport. It contains information on airports, heliports, and seaplane bases that are open to the public. The AFD is published in 7 books, which are organized by regions and are revised every 56 days. The AFD is also available digitally at www.naco.faa.gov. This figure contains an excerpt from a directory. For a complete listing of information provided in an AFD and how the information may be decoded, Refer to the directory legend sample located in the front of each AFD. In addition to airport information, each AFD contains information such as special notices, Federal Aviation Administration and National Weather Service telephone numbers, preferred instrument flight rules routing, visual flight rules waypoints, a listing of very high-frequency omnidirectional range (VOR) receiver checkpoints, aeronautical chart bulletins, land and hold short operations for selected airports, airport diagrams for selected towered airports, en route flight advisory service outlets, parachute jumping areas, and facility telephone numbers. It would be helpful to review an AFD to become familiar with the information it contains. Notices to Airmen, NOTAMs. NOTAMs provide the most current information available. They provide time-critical information on airports and changes that affect the national airspace system and are of concern to IFR operations. NOTAM information is classified into 3 categories. These are NOTAM-D, or distant, NOTAM-L, or local, and Flight Data Center, FDC NOTAMs. NOTAM-Ds are attached to hourly weather reports and are available at Automated Flight Service Stations, or FSS. FDC NOTAMs are issued by the National Flight Data Center and contain regulatory information such as temporary flight restrictions or an amendment to instrument approach procedures. The NOTAM-Ds and FDC NOTAMs are contained in the NOTAM publication, which is issued every 28 days. Prior to any flight, pilots should check for any NOTAMs that could affect their intended flight. NOTAM-D information includes such data as taxiway closures, personnel and equipment near or crossing runways, and airport lighting aids that do not affect instrument approach criteria, such as Visual Approach Slope Indicator, VASI. NOTAM-D information is distributed locally only and is not attached to the hourly weather reports. A separate file of local NOTAMs is maintained at each FSS for facilities in their area only. NOTAM-D information for other FSS areas must be specifically requested directly from the FSS that has responsibility for the airport concerned. Airport markings and signs. There are markings and signs used at airports which provide directions and assist pilots in airport operations. Some of the most common markings and signs are discussed. Additional information may be found in Chapter 2, Aeronautical Lighting and Other Airport Visual Aids, in the Aeronautical Information Manual. Runway markings. Runway markings vary depending on the type of operations conducted at the airport. This figure shows a runway that is approved as a Precision Instrument Approach runway and some other common runway markings. A basic VFR runway may only have centerline markings and runway numbers. Since aircraft are affected by the wind during takeoffs and landings, runways are laid out according to the local prevailing winds. Runway numbers are in reference to magnetic north. Certain airports have 2 or even 3 runways laid out in the same direction. These are referred to as parallel runways and are distinguished by a letter added to the runway number. For example, runway 36L, left, 36C, center, and 36R, right. Another feature of some runways is a displaced threshold. A threshold may be displaced because of an obstruction near the end of the runway. Although this portion of the runway is not to be used for landing, it may be available for taxi, takeoff, or landing rollout. Some airports may have a blast pad, stopway area. The blast pad is an area where a propeller or jet blast can dissipate without creating a hazard. The stopway area is paved in order to provide space for an aircraft to decelerate and stop in the event of an aborted takeoff. These areas cannot be used for takeoff or landing. Taxiway markings. Aircraft use taxiways to transition from parking areas to the runway. Taxiways are identified by a continuous yellow centerline stripe and may include edge markings to define the edge of the taxiway. This is usually done when the taxiway edge does not correspond with the edge of the pavement. If an edge marking is a continuous line, the paved shoulder is not intended to be used by an aircraft. If it is a dashed marking, an aircraft may use that portion of the pavement. Where a taxiway approaches a runway, there may be a holding position marker. These consist of 4 yellow lines, 2 solid and 2 dashed. The solid lines are where the aircraft is to hold. At some towered airports, holding position markings may be found on a runway. They are used when there are intersecting runways and ATC issues instructions such as cleared to land, hold short of runway 30. Other markings. Some other markings found on the airport include vehicle roadway markings, VOR receiver checkpoint markings, and non-movement area boundary markings. Vehicle roadway markings are used when necessary to define a pathway for vehicle crossing areas that are also intended for aircraft. These markings usually consist of a solid white line to delineate each edge of the roadway and a dashed line to separate lanes within the edges of the roadway. In lieu of the solid lines, zipper markings may be used to delineate the edges of the vehicle roadway. A VOR receiver checkpoint marking consists of a painted circle with an arrow in the middle. The arrow is aligned in the direction of the checkpoint azimuth. This allows pilots to check aircraft instruments with navigational aid signals. A non-movement area boundary marking delineates a movement area under ATC. These markings are yellow and located on the boundary between the movement and non-movement area. They normally consist of 2 yellow lines, 1 solid and 1 dashed. Airport signs. There are 6 types of signs that may be found at airports. The more complex the layout of an airport, the more important the signs become to pilots. This figure shows examples of signs, their purpose, and appropriate pilot action. The 6 types of signs are mandatory instruction signs, red background with white inscription. These signs denote an entrance to a runway, critical area, or prohibited area. Location signs, black with yellow inscription and a yellow border, no arrows. They are used to identify a taxiway or a runway location, to identify the boundary of the runway, or identify an instrument landing system, ILS, critical area. Direction signs, yellow background with black inscription. The inscription identifies the designation of the intersecting taxiways leading out of an intersection. Destination signs, yellow background with black inscription, and also contain arrows. These signs provide information on locating things, such as runways, terminals, cargo areas, and civil aviation areas. Information signs, yellow background with black inscription. These signs are used to provide the pilot with information on such things as areas that cannot be seen from the control tower, applicable radio frequencies, and noise abatement procedures. The airport operator determines the need, size, and location of these signs. Runway distance remaining signs. Black background with white numbers. The numbers indicate the distance of the remaining runway in thousands of feet. Airport lighting. The majority of airports have some type of lighting for night operations. The variety and type of lighting systems depends on the volume and complexity of operations at a given airport. Airport lighting is standardized so that airports use the same light colors for runways and taxiways. Airport beacon. Airport beacons help a pilot identify an airport at night. The beacons are operated from dusk till dawn. Sometimes they are turned on if the ceiling is less than 1,000 feet and/or the ground visibility is less than 3 statute miles, VFR minimums. However, there is no requirement for this, so a pilot has the responsibility of determining if the weather meets VFR requirements. The beacon has a vertical light distribution to make it most effective from 1 to 10 degrees above the horizon, although it can be seen well above or below this spread. The beacon may be an omnidirectional capacitor discharge device, or it may rotate at a constant speed, which produces the visual effect of flashes at regular intervals. The combination of light colors from an airport beacon indicates the type of airport. Some of the most common beacons are flashing white and green for civilian land airports, flashing white and yellow for a water airport, flashing white, yellow, and green for a heliport, and 2 quick white flashes alternating with a green flash, identifying a military airport. Approach light systems. Approach light systems are primarily intended to provide a means to transition from instrument flight to visual flight for landing. The system configuration depends on whether the runway is a precision or non-precision instrument runway. Some systems include sequenced flashing lights, which appear to the pilot as a ball of light traveling toward the runway at high speed. Approach lights can also aid pilots operating under VFR at night. Visual glide slope indicators. Visual glide slope indicators provide the pilot with glide path information that can be used for day or night approaches. By maintaining the proper glide path, as provided by the system, a pilot should have adequate obstacle clearance and should touch down within a specified portion of the runway. Visual Approach Slope Indicator, VASI. VASI installations are the most common visual glide path systems in use. The VASI provides obstruction clearance within 10 degrees of the extended runway centerline and to 4 nautical miles (nm) from the runway threshold. The VASI consists of light units arranged in bars. There are 2-bar and 3-bar VASIs. The 2-bar VASI has near and far light bars, and the 3-bar VASI has near, middle, and far light bars. 2-bar VASI installations provide one visual glide path, which is normally set at 3 degrees. The 3-bar system provides 2 glide paths, the lower glide path normally set at 3 degrees, and the upper glide path 1/4 degree above the lower glide path. The basic principle of the VASI is that of color differentiation between red and white. Each light unit projects a beam of light, a white segment in the upper part of the beam and a red segment in the lower part of the beam. The lights are arranged so the pilot sees the combination of lights shown in this figure to indicate below, on, or above the glide path. Please help us spread the word about Pilot Training System, and we look forward to further servicing your flight training needs.